The third part of the infrared spectroscopy. So earlier I mentioned about energy has to go somewhere. So the molecule, so you have your sample, you have your molecules in this box, um, uh, molecules in this box, and the light comes through, and then light is absorbed, and then that absorbed energy has to go somewhere and has to do something. And that energy is used to actually vibrate the molecule. So this is what happens. So let's say you have a carbon dioxide. So I'm just going to draw carbon dioxide. So Lewis structure. And then infrared light comes in, and then the energy is absorbed, and then this molecule vibrates. So let's say here's carbon. You have two oxygens right here. So this oxygen right here is, it's connected with double bond. But now they vibrate, so it can vibrate like this, or it can vibrate asymmetrically, so it can vibrate like this. And of course, it can rock, so it can go vibrate like this too, or it can vibrate like this, or it can vibrate like this. So again, so I'm just going to draw one mode of vibration. So just let's say, so one side goes like this, and then one side is shorter, so they vibrate into a translational way like this. So now again, there's a vibration. So, so again, like I said, IR infrared light is absorbed by, in this case, carbonyl, so carbon oxygen bond, and cause, bonds, depending on how many you have, causes them to vibrate. And this light is being absorbed at a certain specific frequency. So typically this happens at about 1670 wave numbers. It varies, but right around 1640, 1670 wave numbers is where it happens. Or somewhere in that range. So anyways, so in this case, there's an IR table. So again, certain bonds, right? Certain bonds absorb at a specific specific wave numbers. So wave number. So in this case, so let's see, what else can I think of? Let's say the carbon bond, let's see, the C double bond, C and then H. So let's say this CH bond, so CH bond, or I call it sp2CH, occurs at, like, say 3100 wave numbers. So keep that in mind. So what does it mean? So you have your spectrum, and then you have, let's say, I'm just going to draw 4000 right here, and then 500 wave numbers. And then, so here transmittance, so percent T, which means, so light comes in, and then let's say it's going to be absorbed like this, and then it gets absorbed like this and like this. So let's say this part right here happens to be, let's say this part right here happens to be 1670. This part right here is, let's say, right around 3000 range, but we don't worry about that. So then this indicates right here, indicates the presence C double bond O. So keep that in mind. Now, for C double bond O, it's typically, medium to, medium to strong. Medium means roughly about, 50% transmittance. So, and then almost down here is 100%, well, 100% transmittance, and then 0% transmittance. Oops. 0% transmittance. So 0% transmittance is 100% absorbent, because 0% is transmitted, which means the 100% is being absorbed. So keep that in mind. So let's use an example. So let's say, for the sake of argument, let's say, in fact, before we start moving on to the actual example, let me actually go over one more concept. Well, you know what? I'll just stop right here for the time being. So the table, I'm going to actually, in the next video, I'm going to actually put up the table, and then as well as the how to make interpretation of these tables. So stay tuned, and I'll see you in the next video.